In the block 3, the results are summarized in order to form a high-level representation of the input. The input is then classified by logistic regression. The extensive usage of CNN and sharing of parameters helps in keeping the parameter budget at check, which helps in overfitting and other problems. Band-specific representation learning and fusion via concatenation makes the network discriminative towards spectral locality. Major contributions of the present paper are a novel end-to-end deep learning neural network architecture which shows second best performance on the leaderboard in consideration to HSI benchmark HSI classification datasets. The design aimed at efficient band-specific feature learning, keeping the number of parameters low. Also, a considerable improvement in training time when compared to other deep learning architectures have been seen. The architecture. The input is given as a pixel xi of the image and its p cross p neighborhood in the form of p cross nc, where nc is the number of spectral channels of the input. The output is the class of the pixel. The entire network is differentiable and can be trained by backpropagation. Block 1. Block 1 splits a given cuboid of input into nb number of different non-overlapping contiguous spectral bands where each band has a bandwidth of n by nb. Psi function splits the activation map or the feature blocks where the phi function applies the feature selection. There are two different kinds of feature selection used, one being the trivial identity function and the other being 1x1 spatial convolution. Psi takes p cross n in as the input volume and gives out p cross n out as the output volume. NB is a hyperparameter that can be set considering the performance on the validation set. Block 2. Here, NB number of parallel networks are applied, one for each band. Each convolution and fully connected layer is followed by a rectified linear unit. The outputs are concatenated and fed into block 3. In block 3, a fully connected layer is used to summarize the input into block 3, which is again followed by a rectified linear unit. A C-way softmax layer does the final classification by calculating the conditional probabilities for each of the C output classes, which in this case is 9. A total of 4 different architectures have been explored and mentioned in the present study. Each convolution and the fully connected layer is followed by a rectified linear unit except for the last one. PS indicates parameter sharing. Parameter sharing is on, which corresponds to weights and biases of the networks that are tied, and their update values are then averaged across all the networks during backpropagation. The convolution XY presents a spatial convolution layer with a receptive field of P cross P and N output spectral channels. The convolution lambda represents a spectral convolution layer with a spectral receptive field of size P and N output spatial channels. Features are obtained through a set of 3D filters, one corresponding to each output channel. Convolution XY extends through the entire spectral channel and convolution lambda extends through the entire spatial channel. Every convolution is valid and no zero paddings are involved at any place. This is the dimension-based figure for both the types of convolution that have been performed in the model. The figure of 4 different design choices